Hey guys, want to take a quick look. Seventh graders, you're heading into a new unit, proportionality, okay, and unit rates, and it can be a little conceptual at times. But what I want to do is go over a few things, okay? So first of all, let's make this in something we can see. How about a proportion? Okay. So, first of all, what is a proportion? Well, by definition, it is two equivalent ratios. And I kind of talked to you guys about this in class the other day, but it's pretty simple. If I have, let's say, one teacher for every 25 students, say we're in class, that's the same. We would expect 3 teachers for every 75 students. Okay? These are ratios. 2 equivalent ratios, okay, is a proportion. All right. The reason why we study proportionality is because of 2 things. One, it helps us continue to make relationships between numbers and values and quantities. Notice how I'm using a lot of these words, okay? But it starts setting us up with equations, okay? So I've got a couple of examples that I'm going to write out over here. And these actually came from our Imagine Math stuff, okay? So the first one, let's go up here on the number line, okay? You had, let's say this is time and this is distance in miles, okay? And we'll make this one, we'll go ahead and put 0 there. And again, it's a blank number line, so we can do that, okay? And we had 1, 2, 3, 4, 5 miles. Now, the basic information that they gave you was that it took, and I'm looking at my notes here, okay? It took a time, and we'll say this is in hours. It took half an hour to go 2 miles, okay? Well, then, how many minutes will it take to go 3 miles? Okay, not a problem. We know half an hour is 30 minutes. 0 hour is 0 minutes. So half of that is going to be 15, okay, which makes half of a half a fourth, okay? So this is just using number sense. This isn't even setting anything up crazy, okay? So if we look at that, well, to get to 3 miles, that's 1 plus 2. 15 plus 30 is 45, which also happens to be 3/4 of an hour, okay? So that's how you can use a number line on top and bottom to make that happen. All right, the other one, okay, let's take a look at a second example. This one's also from Imagine Math. Farmer goes out and he discovers it takes 4 gallons of water, okay, to water 14 plants, okay? But then they ask us in the problem, what would it take for 35 plants, okay? For starters, a lot of you are going, wait a minute, Mr. Moore automatically put that into a proportion. Exactly. Because if I know how much it takes to work in a smaller amount, I should be able to figure out what it takes to do a larger amount. Okay? Now, I don't know, I know I'm going to have more gallons, but I don't know like what a multiplier is. And then I look 14 to 35 and I'm like, because it just doesn't make sense. But then I look at this right here and I go, wait a minute. If I divide this by 2 and divide this by 2, it gives me 2 to 7. 2 gallons to 7 plants. Hey, that matches up. I can use that. And then all of a sudden, now I really recognize something. What does it take to get from 7 to 35? I multiply times 5. So now I'm going to come up here and go times 5, and 2 times 5 is 10. And now all of a sudden I go, wait a minute. 2 to 7 is equal to 4 to 14. But 2 to 7 is also equal to 10 to 35. Okay? That, even though it doesn't look like 4 to 14 is equal to 10 to 35, that is a proportional relationship. Okay? So hopefully this helps you with some of the vocabulary, gives you a couple of ways to work some of these problems out.